In Chapter 4, we're going to combine sections 1 and 2 and talk about what inequalities are, how to graph them, and how to solve one-step inequalities. So by the end of this lesson, you should be able to identify solutions to inequalities, to graph and write inequalities from graphs, and to be able to solve one-step inequalities just using addition and subtraction. We'll do multiplication and division next. So only one vocab word, or its vocab phrase, solution of an inequality. A solution is any number that makes an inequality true. So for your example that you're going to fill out, I want you to find 3 solutions to x is greater than 6. And one thing to notice here is an equation can only have one solution. Like if we were to solve something like 3x equals 9, the only solution is x equals 3. That's the only thing that works when you plug it back in. But an inequality can have infinitely many solutions. So when you have something like x is less than 3, there's tons of different possibilities. Not only do you have like 2, 1, 0, negative 1, you can keep on going. Like 2.9987 also works. So there's literally an infinite number of solutions that work for an inequality. So identifying solutions, is each number a solution to 6x minus 3 is greater than 10? And now all we have to do is plug them in and see if it makes a true statement. So we're going to do 6 times 1, take away 3, is that bigger than 10? So 6 times 1 is 6, minus 3. We end up with 3 is greater than 10, which is definitely not true. So that means 1 is not a solution. Let's plug in 2. We end up with 12 minus 3. And we get that 9 is greater than 10, which again, not true, so no, this is not a solution. But this next one, we get 18 minus 3, is that bigger than 10? And it is. 15 is greater than 10. So that means 3 is a solution to that inequality. And it's just one of the many solutions to that inequality. So when we graph inequalities, they're a little different than anything else we've graphed before. You have to indicate on a number line where this number is and then show where all of the other solutions are. So I gave you some examples, but let's look at this down here first. If you have a less than or a greater than symbol, you use an open circle. And the reason you use an open circle is because you're saying that that number is not a solution, but everything greater than it or everything less than it is a solution. So like this one up here, if I say I want all the x's that are less than 3, 3 does not work, but anything less than 3 does. So that's why we put an open circle here to show that 3 doesn't work, but anything this way does. And remember, that even includes numbers in between like 2 and 3. So we can't just say that we want everything 2 and less, because we want everything in between there as well. And then if you have the less than or equal to or greater than or equal to, you draw a closed circle. Like this one up here, you're saying I want all the m's, or all the numbers, that are greater than or equal to negative 2. So we're okay with it being negative 2, and then anything bigger. And then this one I included, the very last one, just because it looks funny. Whenever you're given something like this, I always start at the letter and then read away from the letter. So this is saying I want all the numbers that are less than or equal to negative 1. You can read it the other way around, that negative 1 is greater than or equal to all my answers, but to me it makes more sense to start at the letter. So that would include negative 1 and then everything less than that. So let's do some examples. Graph each inequality. So we're going to break out a number line. You really only need to put 0 and 1, or this one 0 and negative 3, 0 and 2. Whatever your number is, that's all we were really concerned about. And then figure out, do you need an open circle or closed circle? So this is just a less than symbol, so I want an open circle. I do not want to include 1. And then figure out which way your arrow is going to go. So this says that I want all the numbers that are smaller than 1, or all the numbers less than 1. So all the numbers that are less than 1 are these numbers over here, like 0, -1, -2. A number like 2 wouldn't work, and you can always check this by plugging one of those in. 2 is not less than 1, so we do not want to include that where our arrow goes. For the next one, draw yourself a number line. You have 0 for reference, and then -3. You can draw in the other ones if you want, it doesn't really matter. But then decide open circle or closed circle. This one we want to close it in because we are okay if it equals -3. And then we want all the numbers that are bigger than -3. So everything bigger than -3 is going to be to the right. And then the last one. Draw your number line again. 0 for reference. We got 2 over here. Open circle or closed circle. Hopefully you said open. And then remember, I always start from the letter. So I want all the numbers that are less than 2. So all the numbers less than 2 go that way. And remember, if you get stuck on one of these, plug in some numbers to check. On either side, you have easy numbers to plug in. So plug in 1. Is 2 greater than 1? Yes. So that means it should be in the part where my arrow is. Is 2 greater than 3? Definitely not. So that means I shouldn't go this way to include 3. So now these problems are a little backwards. I'm giving you the graph, and you need to tell me what the inequality is. So for these, you just got to pick a letter. Let's pick M. And then you got to figure out what symbol you need, and then what number you're talking about. So this is on 2. That's the other easy part. So then our symbol. This is a closed circle, so I know whatever symbol I use, I need to have the equal sign underneath it. And then take a look at what numbers are shaded in. 3, 4, 5, 6, all of those numbers are shaded in. So all of those are numbers that are bigger than 2. So that means I need a greater than or equal sign. Do the same thing for the next one. Come up with a letter. Let's say F. And then your number is 0. And then figure out what symbol you need. It's an open circle this time, so that means it won't have an equal sign underneath it. And where 0 is, we're picking all the numbers that are smaller than 0. So we want a less than symbol. Last thing that we got to talk about is using addition and subtraction to solve inequalities. So remember, we've already talked about the addition property of equality and the subtraction property of equality, which says that if you add the same thing to both sides, it's the same thing as if you don't. Now these are the addition and subtraction properties of inequalities. So it just means that instead of an equal sign in here, you can throw in any of our inequalities, the greater than, the less than, the greater than or equal to, or the less than or equal to, but it's still true. As long as you add something to both sides, it still remains not equal. And here, as long as you subtract the same thing from both sides, it still remains not equal. So when you go to solve an inequality, it's basically like solving an equation, except you don't have an equal sign there. So let's do 2 problems. It says solve n minus 7 is less than or equal to -2, graph, and then check your solution. So we need to get n by itself before we can graph this. So think about it just like an equation. N right now is being subtracted by 7. So to undo that, we want to add 7 to both sides. And as long as we do it to both sides, this stays in equal. So I get n is less than or equal to 5. And that's all I need to go and graph it. We'll have 0 for reference and 5 here. We need a nice closed circle because of that. And then I want all the numbers that are less than 5. So it's going to be this way. And when it says to check your solution, just plug in one of the numbers that you've included here. So we could plug in 4, 3, 2, 1. We could plug in 0. Is 0 less than 5? And it definitely is. So let's do the next one. This one's going to use the subtraction property. So I have t plus 3 is greater than or equal to 8. So to get t by itself, all I got to do is subtract 3 from both sides. And I get t is greater than or equal to 5. And then graph it. So this is almost going to look exactly the same. We got 0, we have 5. Again, we need a closed circle because of that. And I want all the numbers that are bigger than 5. So this time I'm going to go that way and include numbers like 6, 7, and 8. And then check it. So plug one of those numbers in. Let's plug in 6. Is 6 greater than or equal to 5? And yes, it definitely is. So that's it. Can you identify solutions to inequalities? And then can you use addition and subtraction to solve them? Make sure you graph the solution when you're done. Write down any questions you have and we can go over them in class together. Have a good night.